I'm Anil Kumar. Welcome to my series on trigonometry. Now we are going to discuss the area of sector and segment in this particular example. I have number of inquiries about finding this area when the angle is given in degrees. So we are going to develop a formula, right? So let's begin with a circle. Let's say this is the circle we need to work on, right? So in this circle, we'll make a segment. So let's say that's the radius, okay, and let me connect these 2 points. Okay, so what we have really here is a circle with a sector. So this is the sector we have, correct? Let me label it as O being the center, R being the radius. So that is isosceles triangle which you see, A and B being the chord, correct? So we need to find, let us say, area of the sector first. So let's work on area of sector. Now area of sector is in the ratio of angle to the whole circle area. So let's call this angle as theta. So area of sector will be equal to pi r square, the area of whole circle, right? So it is basically ratio of area of circle times theta over, if you are working with degrees, then it is going to be 360 degrees. So it could be 360 degrees. Or this could be, so let's first work in degrees. Okay, so in degrees, let's say. Okay, so we get area of circle as pi r square times theta over 360 degrees, correct? So we have one formula here, and let me say here clearly that this is our sector, which is kind of like this, correct? And the area is theta over 360. Now the same thing, if we do it in radians, let's use a different ink for radians. So if I do it in radians, in that case, sector area, so let me write area of sector, will be pi r squared times theta over 2 pi. Now, in radians you will see pi and pi cancel, correct? So what you get really is you get half of r squared theta. Do you see that? So it is a very simple formula to remember. Or you can say r square theta by 2, correct? So that is how you find area of sector. Now, the other part to look into is area of triangle. Okay. Now let's look into the second part, which is area of triangle, which is OAB. Now, area of triangle OAB, let me draw it separately, slightly bigger one. Where we'll draw up a perpendicular from here. Let's say this is our perpendicular, right? In that case, you will notice that these two angles, since this is an isosceles triangle, they will be divided into theta by 2, right? So these two angles are theta by 2. When the sides are r, what is the height and what is this side? So if you look from the theta by 2 angle, which is OAB, let's call this point as D, for example. Okay. In that case, what is OD equals to? And what is AD equal to, right? So we can say sine theta by 2 will be equal to AD by R. So AD is equal to R times sine theta by 2. Similarly, we could also write that cos theta by 2 is equal to OD by R, or we can say OD equals to R times cos theta by 2. Correct? Now AD is half the base. Correct? So AD is also half the base. Do you see that part? So AD is half the base. Anyway, so what is base equals to? So from here we can say, let me write here. So AB, which is base, is equal to 2 times AD, right? 2 times AD. So which you could write as 2 times R sine theta by 2. Perfect. Now from here we can write down the area of triangle. So what is area of triangle? Area of triangle OAB is half of AB times OD, correct? Which is half of AB is 2R sine theta by 2, 2R sine theta by 2, and let me write here, which is equal to half of AB, AB is 2R sine theta by 2, and OD is R cos theta by 2, correct? So that gives you R square here. Sine theta by 2 cos theta by 2 times 2 is sine theta using double angle formula, right? So you could write this as half of R square sine theta, correct? Since this is equal to, since we know that double angle formula, okay, let me give it here. Let me give in this small space, okay? Since we know that sine 2a is equal to 2 sine a cos a, correct? So you can use this formula. So theta by 2, right? So we could actually combine these terms, all this, and get R times R as R squared, and 2 times sine theta by 2 cos theta by 2 is sine theta. So we get half R squared sine theta. Perfect. So for the triangle, that is the area. Now we should be in a position to find area of segment. So area of segment is definitely area of the triangle taken away from the sector, correct? So this area clearly is basically area of the sector take away area of the triangle. That is what we are looking for, correct? Now, if you are working in degrees, right, say, if you're working in degrees, you get this expression, right? Pi r square theta by 360. Here we have r square sine theta by half, correct? So you have to take away this from here, that thing. But if you're working in radians, look at radians. In that case, the area of sector is half r square theta. And here it is half r square sine theta. Do you see that? So you could take half r square common. You could take half r square common. And what you get is theta minus sine theta as your answer. So in radians, the answer is so simple. For area of segment, you get an idea, right? So that is what I wanted to show you, correct? And of course, this is in radians, right? But if you are doing it in degrees, I will not simplify it, but you can. So I'll just write this as, I can take r square common, right? So I could take r square common, or simply write pi r square theta over 360 degrees, take away r square sine theta over 2, correct? So that becomes your formula for degrees. Perfect. So I think that helps. What you also visualize from here, that if you're working in radians for circles, things are much, much simpler. So my suggestion is, given a question, try to work in radians if it's not too difficult, right? So that should help. Using this formula, practice some questions. I hope that will give you good exposure to finding area of sectors and segments. As you know, the area of segment which we found is this, right? So that is the segment we are talking about, right? So when I say area of segment, I'm basically saying, okay, so I'm basically saying that this portion, perfect. So that was the segment we are talking about. This portion, difference of these two areas, difference of sector area and triangle area, perfect. So that's how you should be doing. So I hope you find this explanation clear and simple to understand. Feel free to share your comments and views. If you like and subscribe to my videos, that'd be great. Share my videos with your friends. Thanks and all the best.